Dear colleagues, your attention is presented to a report on the topic Ontologically supported case-based reasoning for decision-making in humanitarian response processes. The authors Olga Chala, Tetiana Bilova, Viktoriia Dyomina, Iryna Pobizhenko, and Tetiana Domina. Humanitarian aid is a type of assistance with rebates for living, which are provided free of charge to the population of areas affected by a humanitarian disaster. Humanitarian aid is characterized by its urgent nature and the necessity for continuous monitoring of the population needs. The main directions of humanitarian response are food security and livelihoods, healthcare, housing and non-food products, water, sanitation and hygiene. Humanitarian response is a complex and multi-stage process where the most important is the time of providing the necessary assistance. The need for humanitarian response may take place over a long period of time. In addition, there are many unplanned factors in the implementation of humanitarian projects. The situation in the disaster zone can change rapidly, which leads to new requirements for the provision of assistance. In the process of decision-making in humanitarian response, the following should be taken into account. The best possible solution is selected because there is no guaranteed solution to the problem. Accumulated experience of solving similar situations is used as the main source for decision-making. Obtained solution can be used in the future with the possibility of their adaptation for new situations. The model of knowledge representation of the subject area determines the efficiency of decision-making. The specificity of humanitarian response requires simple and adaptive models that are easy to apply in rapidly changing situations. Case-based reasoning (CBR) can be used to solve this cluster of problems. It has proven itself when in situations where the principle of regularity is fulfilled and the tasks can have been solved are repeated. The knowledge accumulated by the system can be used to process new scenarios. The CBR process includes four main stages that form the CBR cycle. Retrieve the most appropriate case or cases for the current situation from the case base. Reuse for the retrieved case to attempt to solve the current problem. Revise in the necessity for the resulting solution following the current problem. Retain the newly made decision as part of the new case. The disadvantages of the CBR methods include: does not solve fundamentally new problems, does not take into account previous decision, difficulty in choosing a criterion for extracting cases. The question areas of adapting the case base to cases where it's not possible to extract a similar template. In this case, it's possible to combine CBR with other methods precisely at the stage of case adaptation. Traditional CBR represents knowledge in the form of a parametric description of a situation and its corresponding solution. The parametric representation of a case is the most common, and processing such data requires less support and maintains. However, its significantly reduces the effectiveness of CBR in cases where decisions have to be made under conditions of uncertainty. Ontological cases are used to represent more complex relationships between subjects matter concept. An ontological representation is an explicit specification of conceptualization. It allows you to create a model using the concepts that accepts used to analyze information. The advantage of ontological approach is a holistic and systematic representation of the subject area, which makes knowledge accessible to allows for its series. The slide shows an example of a description of an ontology attributes set. This set is divided into three subjects that correspond to the categories or classes of attributes: essential, territorial, and resultant. The process of searching for a case similar to the current situation is proposed to be carried out as ontology development, which is based on the reuse of existing ontological resources, studying their parameters and formalizing knowledge. The development processes consist of three stages: selecting the ontology that best suits the current situation and adopting it as the main ontology; adaptation and development of the main ontology to eliminate the imperfection of the current situation in terms of territorial, essential, and effective attributes; enrichment of the adapted ontology with new knowledge based on existing taxonomies, the theory and knowledge gained from previous experience using methods of alignment and fusion of cases. The process of searching for a case similar to the current situation is proposed to be carried out as ontology development, which is based on the reuse of existing ontological resources, studying their parameters and formalizing knowledge. The development processes consist of three stages: selecting the ontology that best suits the current situation and adopting it as the main ontology; adaptation and development of the main ontology to eliminate the imperfection of the current situation in terms of territorial, essential, and effective attributes; enrichment of the adapted ontology with new knowledge based on existing taxonomies, the theory and knowledge gained from previous experience using methods of alignment and fusion of cases. The conceptual proximity of ontologies can be evaluated as the proximity of taxonomies. If a term exists only in one ontology and is absent in the second ontology, the terms of the semantic copy corresponding to term 1 and all concepts in the second ontology are compared. The maximum is taken as the taxonomic proximity with respect to this term. This operation is done for each term in the first ontology, after with the taxonomic proximity for the two ontologies is calculated at the average of the lexicon of concepts in the first ontology. To conduct the experiment or a classification of threats that lead to the need for humanitarian response was carried out in accordance with the Humanitarian Response Plan of Ukraine for 2024. The main clusters of humanitarian assistance have been identified. For each cluster, an initial classification of three types and typical response scenarios have been identified. A fragment of the threat classification for the water, sanitarian, and hygiene cluster is shown in the table below. Based on the classification and data from open sources, 50 ontological representations of precedents were developed to reflect that relationship between emergencies and humanitarian assistance scenarios. Examples of ontologies are shown in the figure. In addition to hierarchical relationships, the ontologies contain object relationships between concepts, which allows for logical inference. Let's consider an example of the development of an ontological case that was determined to the closest to the current situation at the first stage of CBR. Figure shows a fragment of case O1 in the process of its development, case O2 in the process of its development, case O1 with a new branch. The result is the case enriched O1. The slide shows an example of the enrichment stage in the process of finding drinking water for the population. As you can see, when enriching the ontology, you can use the found cases where lexicons have partial overlap. The decision is made based on the found coefficients. In the search of experiments, we evaluated the classification quality on the initial datasets using the parametric and the ontological representation of cases. In both cases, the database was initially filled with 10 cases. Each subsequent case out of the 50 developed cases was fed as a new situation requiring a decision, after which the cases was searched and adapted using the appropriate CBR methods. The resulting solution was compared with the solution contained in the original case, and its quality was assessed. As can be seen from figure, in the case of the parametric representation of cases, when the database is filled with 10 cases, the classification quality is 36%, and then gradually increases with the database replenishment and reach 89% when the number of cases is 50. When using the GBR extended with ontologies, the classification quality increased from 40 to 94% with the same number of cases. That is, we can conclude that use of ontologies in the proposed CBR increases the quality of the CBR by an average of 5%. The extension of the traditional CBR with an ontological components allow taking into account not only previous experience, but also conceptual and semantic connections between the concepts of the subject area, as well as extending them with rules of logical inference. Additional stages of adaptation and enrichment of ontological cases using semantic proximity measures allows obtaining an effective solution even in the face of incomplete information about the current situation. Another advantage of the methods is the high quality of classification even with a small case database. The use of adaptable methods and models of knowledge representation at all levels of management will increase the efficiency and timelines of humanitarian assistance. The proposed modified CBR with ontological components can be used in the development of decision support system for both voluntary organization and charitable foundation providing humanitarian assistance, as well as for specialized services, government and local authorities. Authors' contacts are presented on the slide. Thank for attention.